So for example 2, find the period and amplitude of the function. Find the minimum values, the maximum values, and the zeros on the interval from 0 to 2 pi. Because remember, this function goes forever to the right and left, so we're actually restricting it to 0 to 2 pi. So we're going from looking at here to here. So the period of our function is pi. Okay, I can see it from here to here, or here to here. The amplitude is 4. The minimum value is at -4. The maximum value is at 4. And the zeros are where it crosses the x-axis on that interval. So the zeros are going to be, if this is pi, right here has to be pi over 2. So the zeros are in between 0 and pi over 2. So the zeros are at pi over 4. This would be 3 pi over 4. This would be 5 pi over 4. 7 pi over 4. So I'm going to write those out. So it's pi over 4. 3 pi over 4. 5 pi over 4. And 7 pi over 4. If you're having a hard time seeing that or thinking about it, I'm going to zoom in a little bit. So, think of a number line, and we know that this is 0, and pi was marked right here. So, this over here would have to be pi over 2. This is half a pi. So, a fourth of pi would be right here, pi over 4. So if you go 0 pi's over 4, 1 pi over 4, 2 pi's over 4, that's the same thing as pi over 2. 3 pi over 4, 4 pi over 4. I'm just going up by a fourth each time. 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. 8 pi over 4 is going to be at 2 pi. Okay, that's how I'm doing that with the fraction. Example 3, write a cosine function for each. So assume A is positive. So if the period is pi over 4, I'm going to find my B. So I do period equals 2 pi over B. So in this case, B has to be 8. So my equation is going to be y equals 3 cosine of 8x. So the relationship is the greater your b value, the lower, or your period will go down. Okay, the more cycles you have, the shorter the period will be. Okay, the second one, so I do period equals 2 pi over b. So b has to be 1. And my amplitude is 2, so it's going to be y equals 2 cosine x. And then the third one, the period is 1. So it doesn't have a pi in it, that's okay. So 1 equals 2 pi over b. Solve for b, so b equals 2 pi. So my equation is just going to have a pi in it. So it's going to be y equals 1/2 cosine of 2 pi x. Don't forget to put the x in there. So pi, people get confused, that is not a variable. Okay, so pi is an actual irrational number. So don't just stop at 2 pi, make sure you put the x in it. And then down here, we're going to graph. So the amplitude is 2. The period is going to be 2 pi over b. So b is 1/2. So if you have 2 pi divided by 1/2, if you're dividing by a fraction, you're actually going to flip it over. So it's going to be times 2 over 1. So the period is 4 pi. And it has not been reflected because the a out front is positive. So to graph this, what I'm going to do is I'm going to make my amplitude go up to and down 2. And I'm going to have one cycle from 0 to 4 pi. So if I did have a scale that was 4 pi right here, and this was 2 pi, the cosine function is I'm going to split up my 4 pi into fourths, so 2 to negative 2. The cosine function, because it's positive, starts at the top. So it's going to go 0, or I'm sorry, max, 0, min, 0, max. And it's going to kind of make a U, okay? So I'm going to have to stretch this out because I only have a scale going up to 2 pi right here. So what's going to happen is I have my max right here as 0, or my max at, x equals 0. And then right here is going to be my 0 and then my min. So it's going to look like this. So this is half of a cycle. So I'm going to repeat the cycle over here. So from here to here, we have one cycle. From negative 2 pi to 2 pi, we have one period, because a period's 4 pi. So that's how you do one that's stretched out. Okay, the amplitude, again, this should be amplitude. So is 1. The period is 2 pi over 4, so it's pi over 2. And then, yes, it's been reflected. So I'm going to go to the period, the amplitude is 1. And then the period goes from 0 to pi over 2. So I'm going to do one cosine cycle in here. So I'm going to split this up into fourths. And I'm going to start at the max and go 0. Well, actually, let's look up here. I start at the min because it's been reflected. So I have to pay attention to that instead of starting at the maximum, I'm going to start at the minimum. So I'm just going to zoom in and graph it. So I'm starting at the min, and I go minimum, 0, maximum, 0, minimum. So curvy. And I'm going to keep that going on. I have the luxury of zooming out, zooming in and out. So my function looks like this. Okay, and I can complete it on the left-hand side. And then I'll do one more. So, this is a sine function. So the sine function is going to have an amplitude of a half. The period is 2 pi over 2, so that's just pi. And it's not been reflected. So I'm going to go up a half. I'll call this a half. This is 1. Down a half. And remember, it's a sine function. So sine starts at 0 and goes 0, max, 0, min. 0, max, 0, min.